Hello students, welcome back to our series of solving the JEE mains recent ongoing shift papers, of course, of maths these days. So see, now today we are here with today's 28 January first shift morning shift paper, math paper. See, if I before solving it, if I want to analyze the paper, I will say okay, it was a bit more than moderate a paper. I mean more than moderate means somewhere between moderate and difficult. Okay, but it's not difficult at all. Why? See, there had been, see, I got just 14-15 questions till now, so I'm just on the basis of like those questions I'm telling you all that the paper was like those questions, like look at this question, the first question. So those who have really practiced well, okay, so they know which type of question is it, how do we start it. So many routine type of questions have been asked. They might be lengthy. Like they have asked to find the image of a line. Now it's a highly anticipated paper. If you go back and watch our that video, must do questions or most expected questions from 3D geometry, those are the questions which we always talk about. Okay, so of course that's one of very highly anticipated question from 3D geometry. Likewise, that's a question. Okay, so such type of question has already been asked in the previous year, so that's again a very well known question here. So I will say it was just more than a moderate paper, a bit more on difficult side because maybe of the length of the questions, maybe on a few tricky questions have also been asked. Otherwise it was a doable question, I mean doable paper. I mean that okay, if you have attempted like around I will say 14-15 questions, that will be a decent score. 14-15 correct questions, so that will be really a decent score in this paper as far as mathematics is concerned. So let's start. So now that's the relation here. We are given f of x is 2 raised power x over 2 raised power x plus root 2. Of course they have changed the format, but then how do we start it? Okay, so it's like we have to find f of k by 82 where k goes from 1 to 81. Now what? See, the first thing, so if you open this summation, see, that's what I always do whenever I have to solve a series. Then the first given in the form of a summation, if I don't find any pattern, any direct result formula, then I just open the summation. So if you open it, so what have they asked? 1 by 82, f of 2 by 82, f of 3 by 82, and so on, f of 81 by 82. Okay, so how many terms do we have here? We have 81 terms here. We have 81 terms here, which is 41. I mean 41 is the middle term. Before that we have 40, and then 42 to 81 again we have 40 terms. Okay, now see, that's what I said. Looking at it, the first thing we try is if we add 1 by 81 plus 81 by 80, it's 2. 82 by 82, this is nothing but f of 1, something like that. Okay. Now, so that means this gives you something which is a constant. Okay, so why not to try here f of 1 minus x? Why? Because if I add to x 1 minus x, you get 1 here, as simple as that. So if we get a pattern, and that's what we always try in such type of question. Okay, so what do we get? So 2 raised to the power 1 minus x upon 2 raised power 1 minus x plus root 2, which is 2 raised power half. So it is nothing but 2 upon 2 raised power x, 2 upon 2 raised power x plus root 2. Okay, now take root 2 common from here. So root 2 is 1, this is root 2, and then this is root 2. And then take 2 raised power x as LCM. So root 2 upon root 2 plus 2 raised power x. Now add them. So if I add fx plus f of 1 minus x, what do we get, bachon? What do we get? So they add up. Of course we have same denominator in both of them, here and here. So if you add up, numerator added up, and we get 1 here, and that's it. Okay, so what does that mean? That simply means f of 1 by 82 plus f of 81 by 82. So that's 1. Similarly, f of 2 by 82 plus f of 80 by 82. That's again 1, and that's it. So how many times? So we have 40 such pairs. Okay, so 40 such term, and the last term is f of half, f of 41 by 82, which is f of half. So f of half, I think we can easily find out. So it's root 2 upon root 2 plus root 2. So how much is it? That's half. If I'm not wrong, 2 root 2, yeah, that's half. Okay, so the answer should be 40 plus half. So if 81 by 2 according to me is the answer. So okay, so I don't think I have missed any calculation, but that's it. See, again, the purpose of these solutions is to just tell you what and where to use, what the concept we can apply in just solving these questions, the type of questions you got, okay, so that you may be a bit more mentally prepared at least for the upcoming paper. Now that's the next one, 3an plus 2. So 3 times an plus 2 is equal to 5 times an plus 1 minus 2 times an, right? A naught is 0 and a1 is half. See, there they have asked a very limited like a series with very limited number of terms, n goes from 1 to 5. That should be an, of course that's a correction here, n goes from 1 to 5. Okay, so what we can just try here is, we can say, okay, let's just open it, a1, a2, a3, a4, a5. So that's one aspect of doing it. I mean, we have, like, if we put the value here, so 3 times a2 is 5 times a1, which is half, and then 0. So we got a2, which is 5 by 6. Similarly, 3 times a3 is 5 times a2, which is 5 by 6. Okay, and then minus 2 times a1, which is half, and then you can find just 2-3 more values and get it. But see, looking at it, if we go on writing it, just go on writing it, bacho, like a2. Okay, so it's 5a1 minus 2a0. Fair enough. Then 3a3 is 5a2 minus 2a1. See, that's a pattern which I can see here, bacho. So it's 5a3 minus 2a2, and then 3a5 is 5a4 minus 2a3. Right, now just add them up. So what do we get? 3 times a2 plus a3 plus a4 plus a5. Mind it that we need a1 plus a2 plus a3 plus a4 a5. Okay, so what do we get? When you add up, you get 3a1. See, these two get simplified, 3a1, and that's 0. Okay, and then this is 3a2, 3a3. So 3a1 plus 3a2 plus 3a3, and then extra one is 5a4. Okay, so that's again a pattern here. Okay, so will that help us? So if I add here a1, so it's 3 times a1 plus a2 plus a3 plus a4 plus a5. That's what we need. Okay, which is 3 times a1 plus a2 plus a3 plus a4. Okay, I am taking out 2a4 from here, and then this is plus 3a1 plus 2a4, and 3a1 because we added this side, and then 2a4 which we are left with here. So this is 3 times s. That's what we need, 3 times s, which is equal to 3 times s minus a5. No, actually it got in trouble because, right, just a minute, 3 times s5 is equal to 3 times s4 plus 3 by 2, and then that's the problem. Actually this is the problem. Okay, 2a4. So we need to find 2a4. Actually what I was thinking, that we'll get a pattern between these two numbers, but then maybe I would have mistaken somewhere. See, that's what I analyzed, because when I thought about solving it, I realized that if you go on adding them, the terms are getting cancelled. I mean, if you just go on adding them, this gets cancelled, 3a3, 5a3, 2a3 gets cancelled, 3a4, 5a4, 2a4 gets cancelled. So the terms will go on getting cancelled. Okay, but then the problem is that we need a4 here, isn't that? So we need a4 here. So 3s5. So I mean, we got 3a5 is equal to 3 by 2 plus 2a4. Then that didn't help, no, bacho. Chaliye, anyway, you can analyze it other way also, but then see, maybe that's why they have asked only for 5 terms, or there might be some because since it's a memory based question, might be some error also. But then to find a 5 terms till A5, you will be required to do a bit of calculation here. It's not that easy also, okay, because as we can see here, if you go for A3, it will be 25 by 6 minus 1 whole divided by 3. Okay, so it's nothing but 19 by 18 type of thing. That's your A3. Then you need A4 and one more term A5. Okay, so that's one way of analyzing it. So that's what I thought when I saw just 5 terms here. Okay, but then I thought we will be able to. So just try it. I will also try it maybe after the session. Okay, completing it. I will also try it that way. I strongly believe we will get something out of it. Let me move ahead quickly. See, next is again see. The value of 96 times integral from, this is minus pi by 2 to pi by 2 x square plus cos x upon 1 plus e raised to the power x dx. Okay, now see, of course, what are we going to do? We will be applying Bahubali property, the famous Bahubali property. Why so? Because when we apply Bahubali property here, nothing will change. A plus b, the sum of upper limit and lower limit is 0. So a plus b minus x is simply minus x. So we will be replacing x by minus x here, and that won't change anything in the numerator. So it remains as it is, because cos of minus theta is cos theta. But here it will be 1 plus e raised to power minus x, which we can write after taking LCM like this. And when we know, when we apply Bahubali property, almost every time we add up the given integration and the integration which we obtain after applying Bahubali property. So it's 29 is equal to 96, and when you add up, it's minus pi by 2 to pi by 2, 1 plus e raised to power x here, and then x square plus cos x is common, and then you have 1 plus e raised to power x, and then we can easily, very easily integrate it. So integral of x square is x cube by 3, and integral of cos x is sin x from minus pi by 2 to pi by 2, and that's it. Okay, then you can compare it whatever you need, and we have alpha and beta here. Again, a simple question. See, that's what the question. Okay, about which I was talking about. So you have to find image of the point on the line. So we have already discussed such type of question in detail. Okay, so my approach is simple. Here alpha, beta, gamma is the image point, and that's the midpoint, and this M is also the foot of perpendicular drawn from this point on the line. Now the line passes through the fixed point, which is 1, 2, 1, and drs of the line are 2, 1, 3 bachcho. Okay, so direction ratios of the lines are line are 2, 1, 3. Now how to find foot of perpendicular? Now see, M is any point on this line, so we know how to use this equation, the symmetric form of equation of line. How do we use it? See, the most important application, or what I say is the only way of using this form of equation of line in 3D is to assume a point on that line. So if we need any point on this line, we need x, y, z. So what is x? So it's 2p plus 1, so it's 2p plus 1. Similarly, p plus 2 for y, and 3p plus 1 for z. Okay, now am. So can we write drs of am? Of course we can. We know it's x2 minus x1, so it's 2p minus 3, y2 minus y1, p minus 2, and 3p minus 2 here. Isn't that bacho? Now what? So we know that PM is perpendicular to the line. Now two lines are perpendicular. What does that mean? The product of drs, a1 a2 plus b1 b2 plus c1 c2 is 0. So just do it. So what will you get? So a1 into a2. So it's 4p minus 6, and then plus p minus 2 plus 9p, and then minus 6 is equal to 0. So 4p, 9p, 14p. Isn't that 14p is it? Oh wow, p is 1, and that's it. So you got m. So how much is it? 3, 3, and 4. So m is the midpoint of a and I. So alpha plus 4 by 2 is 3. So hence alpha is 2. Similarly, beta plus 4 by 2 is equal to 3. So beta is also 2. And gamma plus 4 by 2 is equal to 4. So gamma is 4. So the point is 2, 2, 4. Okay, so that should be the answer. So that's a very routine question. Might be a bit lengthy, may take 2 to 3 minutes in completing it, but then it's a very standard question. Okay, so if you get this as a question, you should feel lucky and you should feel happy about it. Now the value of cos of this thing. Okay, Now sine inverse of 3 by 5 plus sine inverse of 5 by 13. Now we know sine inverse of A plus sine inverse of B is sine inverse of A into under root of 1 minus B square plus B into under root of 1 minus A square बच्चों. So it's sine inverse of A 3 by 5. Okay, see, it's simply like if this is sine, you have to get its cos. So cos will be 12 by 13. So it's 12 by 13, or you can do it other way around, the way I've written it. So it's 5 by 13 into its cos will be 4 by 5. So it is sine inverse of 20 and then 36, 56 by 65. Okay, see, when I am approaching this question, then again, before even trying to solve it, I will analyze these three numbers. Do they form a Pythagorean triplet? So we stand a chance. Why? Because 56 whole square will give you 6 at the last, and 33 whole square will give you 9 at the end unit digit, and you add them, you get 5 at the unit digit, which will be the perfect, which we will get as a unit digit in the perfect square of 65. But still, let's check it out. So 65 whole square. So what's the trick? So it's 25, and then 6 whole square is 36. Add 6 is 42. Okay, similarly 56 whole square. So if I have to do it, I will do it as like this. Again, 55 whole square is 25, and then 5 25 plus 5 is 3025 plus 1 plus 110. How much is it? So 3026. So 3136 बच्चों, ठीक है. And then 32 plus 1 whole square. Why? Because 32 whole square we know 1025 plus 64. So it's 1089. Add them. So right, we got it. So that's it. They are Pythagorean triplet. What does that mean? That simply mean if I write it as cos inverse is 33 by 65. So this is so sine inverse of 33 by 65 plus cos inverse of 33 by 65, and that gives us pi by 2. So cos pi by 2 is 0. Cos pi by 2 is 0. But the moment I was writing this, I had that realization, because see, these are not the identities. I mean, these are not unconditional identities. They come with the proper condition here. Okay, and what is it? See, sine inverse of A plus sine inverse of B can give you anything as direct sine inverse of something only when okay, this sum is less than pi by 2. So that's what we have to check. That's what we have to check before we move ahead. But I believe that should be the case. Okay, or then otherwise you have to go with those conditions, and then you have to remember those conditional identities. Normally I don't prefer it. I never ask my students to, I'm not saying I never, but normally I say, okay, most of the times if you use these results, you will get the answer. But then still, okay, if you remember it, you just check it and accordingly solve it. But then the basic observation here was the Pythagorean triplet, which I believed I will get, and we got it. Okay, so now moving ahead to the next one. The next one is the sum of squares of solution of this equation. So there's a mod. So whenever there's a mod, the only thing I do to start with is to open the mod. So we have two cases here. When x is less than 3 by 2. So solving for the first case here, first case bole to x is greater than equal to 3 by 2. So what do we get? X square minus 2x minus 1 plus 3 minus 1 equal to 0. So what are the roots? So x is equal to 2. So 2 plus minus under root of b square plus 4ac. So the roots are they? No, both of them are not greater than 3 by 2, but one of them will be. So it's b square 4 plus 4 by 2. So it's 2 plus minus 2 root 2 by 2. So it's 1 plus root 2, or it's 1 minus root 2. Okay, so 1 plus root 2, is it greater than? I am afraid neither of them. See, that's for sure negative. Okay, that's gone. But then 1 plus root 2, root 2 is something 1.414, 1.5. Neither of them is greater than 3 by 2. So solving for the next case when x is less than 3 by 2. Okay, so it's x square and then plus 2x minus 3, and then I think minus 4, so it's minus 7 equal to 0. So then you have x is equal to minus 2 plus under root of b square 4 plus 28 32 by 2, okay, or minus. So x is equal to minus 1 plus 4 root 2, so 2 root 2. So and 1 is minus 1 minus 2 root 2. So of course this is less than your 3 by 2. And what about this? 2 root 2. So 2.8, yeah, minus 1 is less than 1.8. Oh no, only one root, because I check it out, bacho. It's 32, 4 root 2, 2 gone, minus 1 plus 2 root 2. Okay, so root 2 is 1.414, so 2.8 somewhere, minus 1 plus 1.8 times. So that's the only root. So why have they asked the sum of squares of solution of this equation? So okay, again, see, so that's the only root. So the square, you just add it up. So 9 minus 4 root 2 is the answer. So there might be some, again, there might be some mistake in somewhere of sign, I believe so. Okay, but otherwise these are the steps which I will follow and which I will suggest you to follow. Okay, because we need the solution to add them to get the sum of the square. Okay, and with this condition that when you remove mod, you have two different cases here. So consider those cases, solve the equation accordingly, and you get the roots and check the condition. Okay, now the next one is NCR minus 1 is 28 and NCR is 56. Okay, then we need NCR plus 1. So see, these are consecutive NCR upon NCR minus 1, which is 2, and what is it? So n factorial by r. See, this I always tell to my students that you should know this ratio. Okay, so that might be I mean quite important in the examination. And see, we got a question where you are given two consecutive ratios. Okay, I mean two consecutive binomial coefficient. If we add them, we will get n plus 1. Okay, that's the trouble. Okay, so let's simplify it. So this is nothing but r, and this is nothing but n minus r plus 1, and this is equal to 2. So it's n by r, the n plus 1 by r is equal to 3, and that's the relation. Okay, so n plus 1 has to be a multiple of 3. So n plus 1 is 3 times r. Okay, so has to be a multiple of 3. So now see, I will suggest you to just try few hit and trial type of thing. Like if I say n is maybe just like, you see, you need 28. So for 28, of course, when you solve, you need 7. For sure, you need 7. Okay, so if I say let n be 7, without 7 you neither get 28 nor you get 56. Okay, so n is 7. So in that case, r is 7 plus 8 by 3, and that's the problem. Okay, so 7 multiple is 14. So let's try 14. So 14, n is 14. 14 plus 1, 15, r is 5. So let's try it. So 14 c 5. How much is it? But then it will be a multiple of 13 also. Again, is there a mistake here? Just a minute. Bacho, let me just quickly check it out. N minus r minus 1, n minus r plus 1 will be the case. Okay, that's gone upon r. N plus 1 by r minus 1 is equal to 5628 r twice. That's fine, that's fine. That's 3. N plus 1 is 3. Because see, again, we have 14c5, we need to have 13 here. There is no 13, it's just 7, and there will be in that case 11 also. That's the problem. 7 would have been the best bet, but then for that 3 is a problem, isn't that? So like if we go for 7c3, what is it, bacho? If we go for 7c3, so 7 into 6 into 5 upon 6, 35. Okay, so 7c4 will be the same thing. 7c2 will be 21. Don't we get 28? Tell you will check the question when we get it finally, or anyone get the answer, because see, that's the relation we got. And see, I can't take risk of solving these two. Okay, though they will give us two relation, but of course we won't be in a position to solve it so easily. That will be a lengthy one. N plus 1 c r. Wait, with this, what if we add them? We get n plus 1 c r, which is equal to how much will that be? 20, 30, 36, 84. and we have n plus 1. But then if I replace n plus 1 by 3r, then also no, we won't be able to simplify it. Okay, wait. Let me try one more thing. If I write this n plus 1 CR by NCR, so it's 84 by 56. Let's see, do we get anything reasonable? R factorial, and this is n plus 1 minus r factorial into n factorial into r factorial into n minus r factorial. 84 by 56. Let's see if we get two equation to a known type of thing, and if it works. Just a minute, bachcho. So it's n plus 1, it's n minus r plus 1. Okay, so then it's like 7, how much is it? 12, no? And 7, 8. Okay, so 4, 3, 4, 2. So we get it as 2n plus 2 is equal to 3n minus 3r plus 3. So it's n same. Now that's what I was expecting actually. We got the same result. Okay, chaliye, maybe I will wait for the final question to be here. Okay, then only we will try. But then won't we get 28 in any 7 CR type of thing? Because if we go for 14, even 14 C2, 14 C13, no. We'll have a multiple of 13 there for sure, and there's no other binomial coefficient with superscript like multiple of 7 before 7 which can give us 28. 7C2 is not the case. 7C3 we saw didn't give us. We'll see later, maybe when we get, but that was the question. See, if everything is okay, would have been okay. That's a simple question. Okay, now number of 5-digit numbers using 1, 0, 1, 2, 3, 4, 5, 6 greater than 50,000. 1, 2, 3, 4, 5. A number which is greater than 50,000 formed by such that sum of first and last digit is not greater than 8. Okay, see, since they have asked the numbers 5 digits which are greater than 50,000, that means a repetition is allowed here, first thing. So what are the possibilities here? We can have 5, we can have 6 here, and we can have 7 here. So these are the just 3 possibilities. Now, last digit, sum of first and last digit shouldn't be greater than 8, the sum of them. So you have 0, you can have 1, you can have 2, you can have 3. That's it. That's it. Okay. So if you have 0 here, then how many possibilities are here? So 1, 2, 3, 4, 5, 6, 7, 8. You have 8 cube possibilities here. Similarly, for out of 8 cube, that 50,000 has to be removed. That one case we will remove. Similarly, we have for 1, 8 cube possibilities. For 2, we have 8 cube possibilities. For 3, we have 8 cube possibilities. So the answer is 4 into 8 cube. Of course, minus 1, barring that 50,000 case. Similarly, for here, it's 0, 1, 2. Again, you have 8 cube possibilities. So 3 into 8 cube, and then for 7, it's 0 and 1, and this is 2 into 8 cube possibilities. So 2 plus 9 into 8 cube minus 1 should be the answer here. So that's my answer for this question. And now moving to the next one. Next question is this, of course, is a circle. X square plus y square. So that's a question on conic section, basically a circle, plus gamma equal to 0. This circle touches the x-axis at a comma 0. So it touches the x-axis and its y-intercept is b. So before drawing, it's good that I read it. So y-intercept is b. So something like this. So this length is b units, bachcho, and that's the point a comma 0. Now see, we know basic theorem says that the line drawn perpendicular to the tangent, which is x-axis in this case here, at this point of contact will always pass through the center. So it's a vertical line passing through the center. So center's abscissa is, which is alpha by 2 here, is a, and ordinate is beta by 2, bachcho. So a is nothing but alpha by 2. Okay, so 2, this should be 2a in that case. So this is alpha. So this is alpha. Now we have to get b square. Okay. Now, what's the radius? So radius here is like center is alpha by 2, beta by 2. So alpha by 2 whole square, g square plus f square minus c. That's the radius. Okay, so alpha square plus beta square minus 4 gamma by 2 is the radius. Okay, now why am I asking it? Because see, if I draw perpendicular from the center to the chord, it bisects the chord. So this length is nothing but b by 2 here. So this is our b by 2 and that's the radius. Okay, so that's the, acha, one more thing, isn't that also the radius? That's the radius, which is a. So we have one more relation here. Okay, and that alpha by 2 is a, so we can replace it with a, just a minute, and we have one more relation. So this is a, this is b by 2, and this is our beta by 2. That's the relation here. So beta by 2 whole square plus b by 2 whole square is equal to a square. So we have a relation which is b square plus beta square is equal to 4a square. We need b square, which is 4a square minus beta square, and 4a square alpha by 2 is a, so alpha is 2a, so alpha square plus beta square, and that's it. So the answer is a comma alpha is alpha comma alpha square plus beta square. That's it, bachcho. Okay, so we have to get 2 alpha and b square in terms of, I don't know, I mean what had been the exact, because getting it in terms of alpha, beta, gamma doesn't make any sense. How would they have given the options? But they might have asked 2a plus b square, something like that. Okay, anyways, we got it. So moving to the next one. Next is this one. E1 is given to us. So E1 is x square by 9 plus y square by 4 is equal to 25 by 4. Of course, this is a horizontal ellipse. Major axis of EI is minor axis of EI plus 1. If AI is the area of this, then we have to find the sum of all these areas. See, area of ellipse is nothing but pi times AB. Okay, so where A and B are the semi-major axis length and semi-minor axis length, that's what we know. But I think there's some problem. Major axis of EI, so that means okay, so that's the E1, let's say that's E1, horizontal ellipse. Of course we can write, I mean we can divide both the side by 25 by 4 and get it. Okay, not a problem. So it will be 225 by 4 and it will be 25. That's it. But major axis is the minor axis of EI plus 1. Major axis is the minor axis. No. If this is E1, then that means E2 has to be bigger than this. No, that's not possible, isn't that? Because in that case, E2, the area of E2 will be more than area of E1, and then E3 area will be, because then its major axis will be the minor axis of the other one. Okay, now that's not possible, bachcho. I don't think that's possible. No, there's some mistake here, because see, area should go on reducing. It should be a reducing area. Okay, it must be a reducing area. So, and one more thing, and that is, see, we are just given in that case also, we are just given these two as the vertices. It's a standard one and that's it. I mean, even if I go with this, so let's say, I mean, just for the sake of example, keeping the calculation simpler. So in that case, it will be x square by the minor axis will be our 9, y square by what is equal to 1. I mean, just giving that major axis is the minor axis, is it sufficient to fix the ellipse? I don't think so. How will we get this number? The E2's major axis length, how will we get it is the question here, isn't that? So I think there's something missing. Otherwise, see, once we start getting it, so what we need is just pi AB, nothing else is required. Okay, we just need, here is pi AB. Just a minute, will it be sufficient? No, I don't think. We need both A and B, no? I think this question is incomplete, so that's my estimation here. Next is, if R is a relation x of y, x plus y is even and both are integers, then R is equivalence, reflexive, transitive. Okay, see, for it to be a reflexive relation. So how we know that a relation is a reflexive relation? So for a relation to be a reflexive relation, every A should be related to A, should belongs to R, I mean the relation. Okay, now here it is, because both are integers. So if you add two integers, it's always a multiple of 2. It's 2 times A is an integer, so it's an even number, so that's reflexive. Now symmetric for sure it is. Why? Because addition commutes. So x plus y is even is same as saying y plus x is also even, isn't that? So if x related to y imply y related to x, and then we say it's symmetric. And now what about transitive? So for transitive we'll say x plus y is even, let's say 2k1, and then y plus z is even 2k2. Okay, then if we add them, so x plus z plus 2y, and since y is an integer, so 2y is even, and this is even. So x plus z is even minus even, which is even. So that's again an even number. So that means it's a simple equivalence relation. So that's it. So now moving to the, I think that was the last one. So those many questions which I got quickly, and here in one or two of them, like particularly I will again suggest, because I myself got I had some idea of using it, but somehow that series one, summation of I goes from 1 to 5. I will suggest you people to go and try it, okay, and then whosoever get like a solution of it or the idea of it, you just comment me using the comment box. And then I think that ellipse one question is there something wrong, because it's not possible that the area is increasing and then you are asked to find the area till infinity. Not possible at all, bacho. Okay, so those were 1 2 things. And then again, see, we need to know, we need to consider, accept that is a memory based questions. Okay, bacho. So maybe down the line, in within 3-4 days, we will be getting the actual paper. Moreover, okay, so the level of paper, so according to me, is still not difficult. My expectation was a bit more difficult paper, but still it's okay. So that's really good for all of you. So now you should be mentally prepared to attempt minimum 14-15 questions. Okay, and that will definitely give you a decent score in mathematics and a good percentile. Good percentile means for sure more than 98.5 or 99 percentile if you get 14 to 15 correct answers, bachcho. Okay, so that's it for today. We will meet tomorrow again with the morning shift paper, bachcho.